let's go over the homework problems from 2.5. Number 1, use the rational zero theorem to list all possible rational zeros for the given function. F of x equals x cubed plus 15x squared plus 15x minus 10. So to do this, we have to look at the factors of the constant over the factors of the leading coefficient. So the first thing you have to do is make sure that your polynomial is in standard form. This one happens to be, so we're looking at the factors of negative 10, or 10, over the factors of 1. Now, since the factors of 1 are just 1 and negative 1, we can disregard this denominator for now and just look at the factors of 10. So those are plus or minus 1, plus or minus 10, plus or minus 2, plus or minus 5. So plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10 are all the possible rational zeros. Now, that does not mean that any of these are in fact a rational zero. To determine that, you would need to do synthetic division, or you could substitute each value into the polynomial to see if you get an output of 0. Number 2, use the rational zero theorem to list all possible rational zeros of the function. F of x equals 3x to the 4th plus 7x to the 3rd minus 9x squared minus 8x minus 6. So we're looking at the factors of 6 over the factors of 3. So the numbers that will divide into 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Over, this time, plus or minus 1, which will not yield any new answers, but we also have plus or minus 3. So we have to take each of these over 1, which will be just those numbers themselves, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and then we have to put them all over 3. So plus or minus 1 over plus or minus 3, plus or minus 2 over plus or minus 3, plus or minus 3 over plus or minus 3, and plus or minus 6 over plus or minus 3. Now, 2 of these will reduce. 3 divided by 3 is 1, so it's already represented. And 6 divided by 3 is 2, it's already represented. So our answers are, and we can disregard the plus or minus from either the numerator or denominator, it doesn't matter. Plus or minus 1, plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 1/3, and plus and minus 2/3. So that's going to be choice, let's see, choice A. 1/3 and the 2/3 are there. And notice how they listed them separate. You can write it with the plus or minus, or you can list them separately. Number 3, for the following function, list all rational possible zeros. So f of x is x cubed minus 3x squared minus 4x plus 12. Now you may notice that this one will actually factor, which is a preferred method when it works and when you're good at factoring. So if you're not sure, or if your factoring is weak, just go ahead and use the rational zero theorem. So the factors of 12, 1 plus or minus 2, 3, 4, 6, and 12. Now, this leading coefficient is a 1, so that's all of the possible rational zeros. Now we're supposed to use synthetic division to see if any of these work. Okay, let's give myself a little more space here. Now, where do you start? Well, that's up to you. I always start with the smallest one and work my way up. Now, we're only required to find one by synthetic division, and then we can see if the reduced degree polynomial will factor. Or you can continue to use synthetic division. So I'm going to start with 1. Remember, in synthetic division, you list all of the coefficients. Okay. You bring down the first number, then you multiply. 1 times 1 is 1. You add, you get negative 2. 1 times negative 2 is negative 2. You add, you get negative 6. 1 times negative 6 is negative 6. You add, you get 6. Now it's this number that I multiply times each of these numbers and then put it here and then add straight up and down. Now, since this remainder is not 0, that means that this is not a 0 of the function. Okay? So I'm going to try minus 1. 1 minus 3 minus 4 and 12. The first one drops down. Then I multiply. Negative 1 times 1, negative 1, add negative 4. Negative 1 times negative 4, 4, add 0. Negative 1 times 0, 0. 12, not 0. So this is a no. Next, I'll try 2. You can skip around, but I just find that I like to go in order. So I'm going to drop down the 1. Then I multiply. 2 times 1 is 2. Add negative 1. 2 times negative 1 is negative 2. Add negative 6. 2 times negative 6 is negative 12. Add 0. That means that 2 is a 0 of this polynomial right here. Now let's take a look at the coefficients that remain. Remember, here we've started with a third degree. We have now divided, so we've reduced our third degree polynomial to a second degree. So that's an x squared, an x, and then a minus 6. Okay, so we have options at this point. Okay, I'm going to write my new polynomial, x squared minus x minus 6, and I could list the factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and I could continue with synthetic division to see if any of these work. But instead, I think I'm going to look at this and see that this will now factor. So x and x. The factors of negative 6, think about this, negative 1 times 6, negative 2 times 3, negative 3 times 2, negative 6 times 1. This is the combination that will give you the minus 1 in the middle. Remember, when you FOIL this out, you'll get a minus 3 and a plus 2, and that gives us this minus x. So the 0 for x minus 3 is x equals 3. The 0 for x plus 2 is x equals minus 2. And we had already found that x equals 2 is also a 0. So in part C, the zeros are 3, negative 2, and 2. Number 4, use the following function to answer parts A through C. List all rational zeros that are possible according to the rational zero theorem. So this time we have a 35 as our constant, so it's the factors of 35 okay, all over the factors of 1. And so since everything's divided by 1, this is irrelevant. We don't even have to worry about it. These are our possible rational zeros. We will use synthetic division to see if we can get one of these to work. Starting with 1, 6 minus 30 minus 35. Bring down the 1. Multiply. 1 times 1 is 1. Add, we get 7. 1 times 7 is 7. Add, we get negative 23. 1 times negative 23 is negative 23. Add, we get negative 58. So no, 1 is not a 0. Negative 1. 1, 6, negative 30, negative 35. Drop this down, you get a 1. Multiply, negative 1. Add 5. Multiply, negative 5. Add negative 35. Multiply, positive 35. Add 0. So yes, this is a 0. This is now reduced to x squared plus 5x minus 35 equals 0. So the possible rational roots are still these that we originally listed. However, I'm looking at this trinomial and I'm thinking about the way that trinomials factor. Okay? In order for this to work, there would have to be numbers that multiply to negative 35 that add to 5. So 1 times negative 35, 5 times negative 7, 7 times negative 5, and 35 times negative 1. These are all the combinations that will multiply to give us a negative 35. But if we put those in here as factors, none of them will add up to 5. This one would be negative 34, this one would be negative 2, this one would be positive 2, and this one would be 34. So none of these will work. Now that means that I have to recognize that the only way to solve this, and by the way, you can do synthetic division with all these factors up here, but if you do that, none of them are going to work. You're always going to have a remainder that's not 0. So you need to recognize that this is a quadratic formula problem. And hopefully you'll recognize that before you go all the way through and test all of those possible rational zeros. So for the quadratic formula, remember that a is the coefficient of the x squared, so we have a is 1, b is 5, and c is negative 35. So my quadratic formula is x equals the opposite of b plus and minus the square root of b squared minus 4ac, and all of that is divided by 2a. Right? So the opposite of b would be negative 5 plus and minus the square root, b squared would be 25, minus 4 times 1 times negative 35. Move this over a little bit. And all of that would be over 2 times 1. So I need to simplify this as much as I can. Negative 5 plus and minus the square root of 25 plus, now be careful, I have a minus here and a minus here. That's going to make it a plus. And 4 times 35 is 140. All of that is over 2. So that's going to be negative 5 plus and minus the square root of 165 over 2. That means there are 2 roots here. Now remember, we did find one root originally. We found that negative 1 is a root. So negative 1 is a root. Negative 5 over 2 plus and minus the square root of 165 over 2. This 2 belongs to both of these, so we must write it under both. And if I want to separate them, negative 5 over 2 plus 165 square root over 2, and negative 5 over 2 minus the square root of 165 over 2. Now I'm going to go back over here and notice what this says. You need to do a decimal rounded to 3 places. So we're not quite finished because we have to go back in here and get decimals for these. So once I do these 2 on the calculator, I end up with 3.923 and negative 8.923. Make sure that you do the entire numerator, get an answer, divide by 2. Do the entire numerator, get an answer, divide by 2. Just to show that these are actually zeros, remember zeros equal x-intercepts. Right? So let's look at this in Desmos. So here I have graphed it. I've typed it in, right? And let's see where these zeros are. This one's at exactly at 1. This one is at 3.923, and this one is at negative 8.923. So even though these are irrational numbers, when you find their decimals, you can see where they are located on your graph.